Hey everyone, I'm Duncan. I'm a solutions engineer at Arize, and today I wanted to show you some object detection modeling and the capabilities that Arize has around CV. So this first page here that I'm showing is the performance tracing tab for this model. This model is a computer vision model that has bounding boxes for object detection. There were some features that were included in the model, so you get the same type of feature breakdown in Arize here for the different tags and features that are ingested. And this is shows the volume of the ingestion and any metrics that are calculated on that data. So next I'm going to go into the embedding tab. And this is where we can view the embeddings for the images and start to get a better idea of what's going on with this data set. So I'm going to start out by filtering it down to this first little section of the data, the earliest data that was ingested. And this chart is showing the Euclidean distance for the embedding space. So the average Euclidean distance. And this first section, it looks like it's pretty low. So we have some pretty stable data here. And in this embedding view, what we're seeing is a UMAP representation that actually takes the latent embedding space and transforms it down to 3 dimensions where it's easier to view what's going on in the space. And it also runs some clustering on the data to kind of pull out points that are closer together in that latent space, that higher dimensional embedding space. And if we pick one of these clusters, we can actually see that these images are all drone images that were pulled from a Kaggle dataset. And they have bounding boxes pulling out people and vehicles in the image. So each of these will have a label. And within Arize, you can also have a confidence score for each of these, and you can use that to calculate the performance of the model if you have an actual label as well. And it will calculate, how well you're bounding those objects. But if we look at some of these examples, we see, people in different locations across the image being picked out. And in this cluster, it looks like most of the examples have people. So if we pick another one of these clusters, we may get something different. So for example, here we get some cars that have been pulled out, some trees this looks like more roads and trees in the images, some bicycles parked along the road. So that's the type of data that we're dealing with here. And with Arize, the nice thing about these clusters is you can pick up on patterns within the embedding space that might identify different types of objects or different locations that are being picked up on within the images. So for example, you see a lot of this seems like a lot of parking lots type data. But that's one of the nice things that you get out of the box with the embeddings. We can also just look at the embedding space and see where there may be some outliers or some clusters that are further apart. And this one, for example, it seems like they're all images of the same type of highway or road with people walking along it. So you can kind of intuitively see what's going on within the space and identify different clusters and what's going on within those clusters. And this is a good starting point for if you want to explore, how the model's performing across the different clusters. If it maybe is underperforming on some of these, that would be something to look at. Another thing that you can do is look at this chart of the Euclidean distance, and this gives us a good sense of how the model, how stable our data set is. So for example, in this section where it kind of spikes up, we may want to see if the images look different, because this is an indication that our data sets moving, the clusters are moving away from the original baseline. So I'll let this generate for a second. And as you can see, this data, it looks like is distributed differently in this cluster where we have the spike of Euclidean distance. And that indicates that's this distance that we're looking at here. So if we pull out the data from this cluster, I think this is probably where we're getting our discrepancy. And yeah, as you can see in this data, it looks like it's more granular. If we click on one of these, it's kind of distorted, and these bounding boxes don't seem to be picking up on anything in particular. So it kind of indicates that the model's not performing well on this data. Like it doesn't seem to be able to pick up on the objects when we have this distortion on the image. So one thing that we can do within Arize once we have this cluster is we can pick some of these points, and we can use the embedding space to find similar points and filter the data set. So I've added a filter now to the data. And if I increase the similarity that is required, so this is going to, we can adjust the threshold for how similar the points need to be. And I remove the baseline. And you can see we end up with just the subset of the data that may be closest to those points. So it looks like these points, we have 355 points, and these are probably all the distorted points in the data set that we have. So that's a nice thing. We can use this, we can download these points, we can dig in more to figure out what's going on here. One thing that we can also do within this embedding space is we can filter on tags and features. So for example, we have a tag for the humidity, and we can see how the data is distributed across that tag. So for example, in this data, it looks like this cluster where we're seeing a lot of the distortion is all more humid in this spectrum. So when we get those higher yellowy green colors, that's an indication that the humidity is higher. Whereas in this cluster, we're seeing a lot of just normal data, and this has much lower humidity where it's a lot of the purples and the blues. So that's one thing that you can also do is you can add tags. I think this weather condition one, we also see a lot of these points are in the cloudy weather. So cloudy, humid data causing that distortion potentially, where we're not seeing quite the same ability of the model to pick up on the correct bounding boxes. And then this is just the normal distribution of the data where we're seeing just like kind of good performance and correct bounding boxes around the objects. So I just wanted to walk through those capabilities of Arize with respect to CV and object detection. And I hope this was helpful. Thanks.